Let's solve this equation using the quadratic formula. Step one is to make the equation look more like this by setting it equal to 0. I'll do that by subtracting x and 1 from both sides of the equation. We get that x squared minus x minus 1 is equal to 0. And at this point, all you need to do is identify what is a, what is b, and what is c. These are the numbers that are located in front of x squared, x, and the constant at the end, respectively. So there's a 1 here, there's a negative 1 here, and a negative 1 at the end, meaning that a is 1, b is negative 1, and c is negative 1. Once you know this, you can just instantly take this, plug it into this expression, and simplify it. So let's go through that process. The solutions to the equation, if they exist, are equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And if we carefully follow order of operation, I think we can simplify this nicely. The negative 1 is 1. We have plus or minus the square root of, I'm just going to type this into my calculator to simplify what's underneath here. I mean, you could really do it in your head too. This is positive 1. This negative gives you another positive, and that's 4. This is 1 plus 4, or simply output 5. And that's all divided by 2 times a, which is just 2. I'm actually going to write out the two solutions separately. The two solutions are 1 plus the square root of 5 over 2, as well as 1 minus the square root of 5 over 2. So this would be like a difficult problem to get the answers by factoring, because these would be the factors that you'd have to guess. So if you have an equation, you can't guess the factors, you could always go to this formula. In problem 2, we have 4 equations, and our goal is to solve them, and we can use any method that we like. Maybe use this formula, perhaps try to factor the equation or something like that. So let's see, or even use a graph. I guess that would be appropriate too. Okay, 6x squared minus 7x is equal to 5. Well, I mean, it would make sense to at least subtract 5 from both sides of the equation, so I think I'll start there. This is 6x squared minus 7x minus 5 is equal to 0. So I think you probably could guess the factors here, but I'm actually going to not do that because I figured, I don't know, it could take me a little bit of time, and we have this formula, so instead I'll identify a as 6, b as negative 7, and c as negative 5. And let's see what happens. According to this formula, the solutions are negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And that means we get a positive 7 plus or minus, and under the square root, again, I think, going to a calculator would be a good idea here. So it's going to be positive 49. The minus and minus becomes a positive, and it's 4 times 6 times 5. This is 169, and this is all divided by 12. And let's see, if I take the square root of that number, it actually is equal to exactly 13. So this works out really well within the formula, because x is equal to 7 plus or minus the square root of 169 is 13, and this is all divided by 12. I think we should actually write out these two solutions. That is, x is 7 plus 13, which I'll put as 20, over 12, as well as 7 minus 13, which is negative 6 over 12. And you can simplify these. 20 over 12 has, a factor of 4 can be divided into both of those. So that's going to be 5/3. And negative 6 over 12 is negative 1/2. So simplified, those are the two solutions. I think it is worth pointing out, if your goal was to factor this expression that was set equal to 0, that your two factors would have been 3x minus 5 and 2x plus 1. So you could have taken a factoring approach, and I bet some of you could have definitely factored the equation like this. 3x and 2x multiplies to 6x squared. Negative 5 and positive 1 multiplies to negative 5. If you check the middle terms, you get a negative 10x, a positive 3x, which adds to a negative 7. So this would have been fine too, and you would have wound up at the same answers. All right, let's check out part B. I think setting it equal to 0 is a good approach, so I'll subtract x from both sides. And since I have a 1 in front of the x squared, I think factoring this, if it works out, would be easy to guess. So let's try that. You have to have an x and an x. It has to be a positive and a negative because the last number is negative. I need two numbers that multiply to 56, negative 56, yet add to a negative 1. I think that is a positive 7 and a negative 8. 7 times negative 8 is negative 56, and the sum of those two is negative 1. Those are my factors. To get the solutions, it's up to you how you write this out. You can set up two separate equations, but what I was saying in class is, well, if you put negative 7 here and add it to 7, it makes this factor 0, making the whole side of this equation equal 0. So I'm just going to note that, well, x is equal to negative 7 is a solution. Likewise, if I look here, if I put 8 in place of x, 8 minus 8 is 0, and that's the other solution to this equation. Okay, so for part C, again, there's a 1 in front of the x squared, so potentially factoring could be a good approach, but the problem is I can't think of two numbers that multiply to a positive 2, yet add to a negative 2. So it's like, I can't think of anything that works. And if that's the case, perhaps just going directly to the quadratic formula is a good approach. A is 1, B is negative 2, and C is positive 2. In the quadratic formula, we get negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And I'll just carefully simplify this. That's 2 plus or minus the square root of, that's 4 minus 8, that's negative 4 all over 2. And at this point, I mean, you could pretty much stop if I was asking for real solutions to this equation. The problem is, that's a negative number under the square root, and if you take the square root of a negative number, you would get an error. I'm actually going to graph the original equation in my calculator to see what's going on here. I'm going to investigate this by, in place of y1, looking at x squared minus 2x plus 2. I'm going to sketch what I see on my window, on my screen over here. So x squared minus 2x plus 2. I see a graph that looks something like this. And when you say, where's my graph equal to 0, that's where it actually crosses this axis, which clearly never happens. You can actually see that in this equation. Like, we're simplifying it, you're going to get an error message, and that must mean there are no solutions. And according to this graph, there aren't any. So you could really even stop right here if you want. You could say, well, the answer to this is there are no solutions. We did have a lesson on complex numbers, so I do want to take this one step further. In that, anytime you have a negative 1 under the square root, you can replace that with the symbol I. So I'm just going to say, as a definition, if you see a square root of a negative 1, we call that the imaginary number I. So if you want to take this one further to simplify this problem, well, the square root of 4 is 2, and the square root of the negative is what we call I. And so you can replace this whole symbol, the 4 under the square root goes to 2, the negative under the square root goes to an I. I'm noting that 2 can go into both of those terms, making them both 1s. So this is x is equal to 1 plus or minus I. So, I mean, there are no, I should probably say, there are no real solutions. But there are two imaginary solutions. The solutions would be 1 plus I, and also 1 minus I. So I think either of these are acceptable for what we're talking about in this class. We're looking at a lot of graphs on the real line, so I think this is fine to write your answer just like that. Okay, part D. I want to solve this equation. And if you want to use this formula to do so, you would have to square this out, combine like terms, and subtract 51 from both sides. But because this is x minus 1 squared, we have another procedure for solving for x. I want to get this portion of the equation by itself. So I'm actually going to subtract 1 from both sides first. So I'm going to take 1 from both sides, which changes this equation to 2 times x minus 1 squared is equal to 50. The second step would be to divide both sides by 2, and that gives you x minus 1 squared is equal to 25. Once you apply the square root to both sides, on the left, we get x minus 1, provided that you put a plus or minus 5 on the other side. You can add 1 to both sides of your equation. This gives you x is equal to 1 plus or minus 5. I think I should write my solutions as x is equal to, well, 1 plus 5 is 6, and 1 minus 5 is negative 4. Those are my two solutions. All right, for question 3, I want to find the vertex of this quadratic, which is either the lowest or highest point on the graph. Any equation in this form is called vertex form. So one thing to point out is that if you know the graph of x squared, this thing is simply a transformation of that graph. Like here, this x minus 4 means go right 4 places. This plus 2 means go up 2. So the graph of x squared starts here. And actually, its vertex, its lowest point, is at 0, 0. I'm going to label it. So the vertex of x squared is the point 0, 0. And the graph is this U shape. But to get to this equation from this one, I'll write down that, well, you're going to go right 4 places, and then you're going to go up 2 places, which means your vertex travels right 4 and then up 2, which is right here. If you simply put this thing into your graphing calculator, I'm going to get a sketch of that on this plane. So it looks something like this. Again, not a perfect graph, but this is the equation you should see. So the point of dealing with a quadratic in vertex form is you can easily understand its graph by transformations. Furthermore, if you set it equal to 0, it's very easy to solve an equation of that form. So let's look at problem 4. The idea is we want to take this equation and locate the vertex. And the issue is this equation has this x in it and not just an x squared. This is not in vertex form. If it were, it'd be very easy to see that the vertex is located at 4, 2, which is right here. We're going to go through a process called completing the square, which eliminates this 8x from the equation, transforming it into something that looks more like this. So I'm going to outline that procedure here. What you do is you look at the number in front of the x, which is an 8, and you take half of it, which gives you the number 4. You then take this number 4 and you square it, and that gives you 16. What we're going to do is add this number to both sides of the equation. And specifically, I'm going to put it right after the 8x. So if I do that, I get y plus 16 is equal to x squared plus 8x plus 16 plus 17. So I added 16 to both sides of my equation. The reason that this is a good idea is that these three terms are now a perfect square. Here's what I mean. On the left, we have y plus 16, and I'm claiming that x squared plus 8x plus 16 is a perfect square. In fact, it's equal to x plus 4 squared. If you think about it, if you square x, you get x squared. If you square 4, you get 16. But you also get 4x a total of 2 times, which doubles back to give you the 8. And that's what this process is trying to convey. It's saying, well, if doubling 4 would take you to 8, taking half of 8 would bring you back to 4. And it's squaring that 4 that takes you out to 16. The last thing to do is solve this thing for y, and you can do that by, again, subtracting 16 from both sides of the equation. And if you do that, let's see, that's minus 16 minus 16, we get y is equal to x plus 4 squared plus 1. That means I know the location of the vertex. It's located at -4, +1, because in terms of transformations, this means go left 4, and this means goes up 1. Let's try that again in part B. All right, what I'd like to do is complete the square by looking at this -10. I take -10 and divide it by 2, which gives me -5. I then take -5 and square it, and I get 25. What I'm going to do is add 25 to both sides of this equation, specifically putting it after the -10x. Okay, so that's y plus 25 is equal to x squared minus 10x plus 25 plus 23. It is, again, these three terms that are now a perfect square. So that is, you have y plus 25 is equal to, well, what perfect square is this? Well, you have to have an x, and it's going to be a -5 at the end. If you square -5, it gives you 25, but if you double -5, it would give you -10. To get y by itself, I'll subtract 25 from both sides of my equation, and I arrive at my answer. Y is equal to x minus 5 squared minus 2, which means the vertex is located at, okay, we're going to go right 5 and down 2.